minus 4x minus 12. And who remembers? Yesterday we said there were 3 ways to solve a quadratic equation. Who remembers? Grace?
Factor, complete a square, and quadratic.
Perfect. And in the real world, you get to do it however you want to do it. Now we are aware that factoring doesn't always work. This one does factor though. Can anybody see how this one factors? Minus 6 plus 2. And we're just thinking in our minds, first of all, negative 6 times 2 gives you negative 12. And when you FOIL this, outside and inside would add up to negative 4. So what are the answers to the question, Harry Payton? What does x actually equal? Set these equal to 0. What would x actually equal?
6 and negative 2.
Yeah, there you go, perfect. Now, what if your teacher told you that you have to complete the square?
Add 12.
First thing, you got to get your equation ready to complete the square. And there are 2 things you have to do to be ready to complete the square. One is, this number has to be on the other side. The other thing is, did we talk about this yesterday? I can't remember in this class. Did we talk about?
If you can.
The leading coefficient must be 1. So if this is something other than 1, you have to divide it out. So if you had the equation 3x squared minus 4x plus 8, and you decided you were going to complete the square, this would be hideous, by the way. But if you decided that's what you were going to do, you would move that 8 to the other side, and then you would have to divide everything by 3. You cannot complete the square unless this coefficient is 1. If it's not 1, make it 1. All right, ours is a little easier. So now we're going to complete the square. So what are we going to do? We're going to add something to both sides. And the thing we add is going to make this a perfect square. Hence the word completing the square, right? So what's going to make this a perfect square? Well, you remember, you take half of 4, which is 2, and you square it, and that is 4. And that makes this perfect square then what? What's this if you factor it?
Minus 2.
X minus 2 squared equals 16. Now what do we do next? Square root both sides. If we are still looking at summer reading, now is the time to put it away before I freak out. We're now doing math. We're taking the square root of both sides. Don't forget this. That is a big place for error. It is so critical that you remember that, because how many answers are you supposed to end up with? 2. And the only way you're going to get 2 is to put that plus or minus in there. So x is 2 plus or minus 4. Here we go. 2 plus 4 is? And 2 minus 4 is? And notice that we got exactly the same answers Harry did. Awesome. Now we're going to use the quadratic formula. Oh shoot, I erased my equation. Oh, it's right here. All right, so in order to use the quadratic formula, groupies, we got to remember the quadratic formula. Okay? So some of you might sing it, some of you might write it. I don't care as long as you know it. X equals negative b. Let's write the formula first. Negative b plus or minus square root of b squared minus 4ac all over 2a. Note that line right there. 2a is under the whole shebang. The whole thing, not just the radical part, but the whole thing is over 2a. Now, what do these a's, b's, and c's represent in that formula?
Ax plus by.
The standard form of a quadratic is ax squared plus bx plus c equals 0. So a is the coefficient on the x squared, b is the coefficient on x, and c is the c is just the constant term. This is called your quadratic term, this is your linear term, and that's your constant term. Quadratic means degree 2, linear means degree 1, constant means it's just a number. So for us, negative b will be 4. B squared then will be now just be careful with your arithmetic. Watch the double negative stuff going on in there. So it's going to be 4 plus or minus the square root of what? 16 plus 48, which would be 64. Oh, that's beautiful, isn't it? Square root of 64 is, of course, 8. So now we have 4 plus 8 divided by 2. And 4 minus 8 divided by 2. And we got Harry's answers again. Of course. Now in a minute I'm going to let you practice all 3 ways, but first we have one more thing to talk about. I don't think we talked about this yesterday. I want to make sure we do. That guy right there, the b squared minus 4ac, the thing under the radical, we call it the radicand, is extremely important. So important, it has its own name. Does anybody know what the name of it is? No? It's called the discriminant. That is exactly right. It's called the discriminant. B squared minus 4ac. Now why is that important, do you think? Well, it was really awesome that discriminant in our problem was 64. Why is that so awesome? Why was that great that we got 64 for our discriminant?
Because it came out
It's a perfect square, which means this radical disappeared, which means that my answers turned out to be numbers without radicals, which makes them rational. Because if this had turned out to be a 63, then my answers would have had radicals in them and they would have been irrational. But it's even bigger than that. What if this had turned out to be a negative 63?
and it's an odd.
Then I would have had imaginary answers, right? What if it turned out to be 0? What would happen if that actually worked out to be 0? Think about that for a minute. What's the square root of 0? 0. So I would have 4 plus 0 over 2 and 4 minus 0 over 2. What about that?
Same answer.
They're the same thing. So what you just told me is that the discriminant gives me a lot of information about my answers. If b squared minus 4ac is a perfect square, then what do I end up with? That's what we had originally before I started erasing things. What kind of answers did I get? Because it was a perfect square, the radical disappeared, and I ended up with 2 rational answers. Would you agree with that? Now what if it's not a perfect square? What if it's positive but not a square? So like 63, it's a positive number but it's not a square. What did I end up with? Or what would I end up with? 2 irrational. What if it's a negative number? Less than 0 means negative. Then I get 2 imaginary. What if it actually equals 0? I get 2 of the same answer, so I can effectively say I have 1 answer. And what kind of answer would it be? Would it be rational or irrational? It would be rational. So, there will be a question at some point in your future that says, what is the nature of the solutions? In other words, what kind of answers do you get? We say that formally. What is the nature of solutions? So I'll give you some quadratic equation, and I'll say, what is the nature of the solutions? In order to answer that, you're going to evaluate the discriminant. And you're going to pay attention to what kind of a number comes out. So what would my discriminant be here? 16 minus 4 times A times C. Not equal 0. We're going to do that for. So what does that equal? 8. Now tell me about 8. Is a positive number, but not a square. So the answer to the question will be 2 irrational roots. Got it? Do you think there's ever a reason people would be interested in knowing what kind of answers they would get before they actually do the problem? I mean, obviously you could actually work it out and get an answer. Do you think there's ever a reason people would want to know before they did the problem what kind of answers they might get? What? Okay, yeah, kind of gives you a clue if you know you're doing it right. What about practically speaking in the real world? Tom?
You probably don't want an imaginary answer.
Not in the real world, we don't usually want that. Exactly right. My husband's a civil engineer, he does roads and bridges and things like that. Suppose he's got an equation for some bridge he's designing. Does he want a negative discriminant? Or do you want a negative discriminant? Heck no. So the nature of the roots, very, very important in the real world. We like positive discriminants. Okay, you ready to try some? All right, let's have some volunteers at the board. Whoever's on this board is going to be on video, but we can use all the boards. I'm going to give you one equation, and I want it done all 3 ways. So somebody's going to come up and do it using completing the square, somebody else is going to factor, and somebody else is going to use the quadratic formula. So here's our equation. Okay, and I would like the completing the square one on the board because this is going to be a little tricky and I'd like to have it on video. Here you go.
Wait, which one am I doing?
You want to complete the square right here?
Complete this one.
Okay, and then I need somebody oh no, not that board, I'm saving that for next period. I need somebody over here factoring and using the quadratic formula. Come on, volunteers. Go, yeah, if you're doing this, raise your hand, just run over, grab a spot. And you get to pick now, do you want to factor or use the quadratic formula?
I'll use the quadratic.
Okay, then I need somebody who can factor. Thank you. And what should the rest of you be doing? You should be doing this right now. Pick a method. Why am I concerned about completing the square in this problem?
Because you have to go to the 2.
No, I have a fraction in it. That's right. We're going to have to deal with the fraction. It's not going to be bad, but we're going to have to deal with it. So remember, you want to take half of that. So over to the side. That's right, 5 halves. No, half of that. Half of that. So right, 5 halves times 1 half. That's how you take half. You multiply by half. So what's that going to give you? 5/4. So that's the number you're going to square.
How did that class?
So that's what you're going to add to both sides.
Square root of 121 is 11.
I can't remember if I told you this yesterday or not. Maggie's using the quadratic formula, and she got a discriminant, and I don't know if this is right or not. Anybody else doing it that way? She got 121 as her discriminant. Somebody else get that? Okay. Now, what's special about 121? It's a perfect square. When your discriminant turns out to be a perfect square, we know that means 2 rational roots. It also means your problem is factorable. So if you are ever wondering if the problem factors or not, do the discriminant. If you get a perfect square, your problem factors. If you don't get a perfect square, it doesn't factor. Okay, sunshine, what did we forget to do over here?
Oh, we forgot to,
How do
Can
you
you add that? You gotta add it over there.
How do you get 25 over
I got
60?
someone at the center.
Okay, keep going. How do we get 25 over 16 to add to both sides? Remember, kids, you take half of this. And when we take half, we literally multiply by a half. So half of 5 halves is 5/4. And then you have to square that. And that's how you get 25/16. You take half of that linear term and square it. Perfect. Now you're gonna need a common denominator. Plus 25 over 16. So what's our common
Dude, I'm
denominator?
screwed. I didn't finish reading the book. I didn't read.
Yep, so times 16.
Yeah, I had,
You are.
when I was reading, I was reading it too.
That's
L
96.
page 160. I was never charged. You know, last time I was reading it the other day, plus I was like, I can do anything this class, so read it that period.
It's
read
not
during
that
class.
fast.
I like your other
And I think
That's
I'm thinking I'm not worried, which is kind of weird. I feel like I definitely should be worried.
now you're gonna take the square root of both sides. So you're gonna put x plus 5 to the first.
We probably should have drank it.
I'll do that too. Okay, I got it.
Plus or minus the square root of
I'll
this.
make a what?
What's the square root of 121?
3 over 2.
You gotta subtract your 5/4. So you have 11/4 minus 5/4.
I'm really bad at factoring, but I had them.
I'm so confident.
And then
Factor this.
negative
That's all I did. That's all I did.
Not officially.
Yeah, if it wouldn't have factored, I would have sat down and like, yeah.
Okay,
How do you get 3x minus 12?
everybody got exactly the same answers. Isn't that magnificent?
Nice job, Steven.
Any question about that?
I'm pretty confused with factoring.
Couple of things quickly, and then I'll let you have a little time to get summer reading organized in your brain, finish your books that you got all summer to read. Remember that in order to use the quadratic formula or to factor, the equation must be set equal to 0. There will be problems in your homework tonight where they don't have it set equal to 0, and you've got to get it set equal to 0 before you can start. All right? Remember, when you complete the square, you have to have a leading coefficient of 1, or it isn't going to work. All right, your homework then is supposed that you're good. Go ahead and get started on that, or get ready for summer reading. I'll give you a few minutes here to get organized. I don't know. Who knows?
40.
Is that the right time?
No, it's not.
9:31.
All the clocks are off.
Except for the right now.
Oh, shoot. Yeah, I told you we were gonna do the calculator today. The ones that say solve graphically, don't worry about those. We'll do that on Monday or tomorrow. We'll do that tomorrow. Or we won't.
See how many
We're not turning in homework today.
Oh, I got 9. I got 7. Okay, I do have 4
I like going in.
I read quarter page
Yeah.
Kidding, I was like,
Okay, I am here.
I'm here. I need to be at the end. Here we go. I have like 9.
Who is this guy?
I don't think I'm included.
I'm just the same room, but I still know. That's how I
What? Since when is that?
Yeah, wait, was she like tweeting about?
I got you.
Okay, just an E. No, but you got me here. I'm gonna go back to page. Like, look at just like look at him. He looks good over here. His backpack is like bright purple and his face is bright.
I think that's his first name's Mel, the fiance of
P3.
what's his sister's name?
No, that's you did P4.
It is.
We're good.
Hey, Scott. Can you carry my book back to my next
It's
class?
this man. This man. The man who says he's a murderer. He doesn't know how, he knows.
Hey, this time right now, I'm trying to be a considerate teacher, given you had this big English test today. If you can use this time productively, I'll just keep yapping. You know I'm a big yapper. Yes, you want to talk about the book, as long as you're talking about the book, I'm okay.
That's what I did all yesterday.
Oh, I don't know that much time.
Plus, we have the shortest names.
I read like 60 pages.
I actually did shoot too.
Oh, the silver shoot. Yeah, that's weird. He just shoots those three kids.
You like
And they go like crazy.
I'm not gonna lie, you have to take it.
I'm like ready for chronicles and like stuff to little tests.
What? I was thinking I was gonna take the reading test and switch out. I read both books. It's like a different
My dad takes me every morning. Thanks, Dad. He just texted me, he's like, I want to hear about how your day went yesterday, how the class went, and how golf was. Oh, yeah.
I know. I
Yeah, I passed on.
Yeah, you have. Wait, so IU grad class goes to IU, no other college?
I like just have my key on the chain.
No, what did
I think just
I obviously at Miami, Ohio.
I came right on the year.
I visited there. I didn't really need it.
Very serious.
I mean, it's just
Too big. Well, it's small compared to junior IU. And I'm really recommending a house.
yeah, that's the only thing. Oh, sigma had first.
No, like, out of Miami, Ohio, like some big pieces of road. I'm gonna bring it back. That's my plan. My dad, like, started.
And then
About it.
so like you had to wait till the second was
All right.
so then he finally and then
Oh, that place.
Wait, you mean
That
like
place. I heard they're crazy. Yeah.
yeah, it's like
So cool.
isn't that where like they all celebrate? Yeah.
People sitting on top of houses.
Like
There's a lot of
Yeah, I feel like there's a lot of people who sit on top of houses.
I mean, I guess like I feel like it's like not that much different considering it's like every chapter's